one end of the horizontal spring, the K is equal to 80 Newton per meter, is held fixed, while the external force applied to the free end A equal to 0 to XB equal to 4.0 centimeters. Ladies and gentlemen, when reading this problem, the problem has no diagram provided to you. You have to generate the diagram. You draw the diagram either here on the left side or the right hand side. So here is a draw spring like this. When he is saying this, is held fixed while an external force is applied to the free end. So this end is called free end. This end is a fixed end. So assuming in these cases he doesn't have an object there. If you don't want to bring the object into account, you just leave it hanging like this. And here is a starting point, in which case he says XA. Effectively, what is showing is something like this. Like this holding. This part is, okay, from your point of view, is this is XA. Okay? So I pull from XA to XB. You understand now? XA to XB. So it pull. So when you pull, and they get a location right here, in which case it's called XB. So extend. So what it's saying that the force is come from horizontally, like that. So he says the A is find the work done. A, find the work done. Now this work is done by what? By the external force, by me. Something I pull like this. So in that case, this force is positive. Okay, so that is the work is equal to positive integration of F dx. Okay, so from XA to XB. Then you have written everything down, XA equals 0. This is considered as a good diagram. On the top of it, you have to say something like in English, like I presented to you by words. I cannot write extension to 4 centimeters. And then another one is the spring constant here is K is equal to, it says 80 Newton per meter. Ladies and gentlemen, look what I did. I did everything onto the diagram. All the information regarding about the problem is on the picture. Okay, so what is asking? Number 1, part A is what? Okay, work is from XA to XB. Then part B, he says, again, in these cases, he says, find the work done on the stretching. So he says, the work done from XB to XC. Okay, so you identify. So in that case, it's asking for work equal to what? From XB to XC. So this 2 is a question you put out on everything as much as onto the diagram. And after that, then if you don't do this kind of thing properly in the exam, we will automatically deduct 25% of the grade. Suppose it's 20 points, you deduct 5 points. If you don't draw this properly. So this is cosec theta 5 points. Okay? So after this is done, then you have 1.5 xb squared k xb squared minus 1.5 k xa squared. Then you substitute. Okay, so here is k is equal to 1.5, k is equal to 80 Newton per meter, the unit. And then xb equal to 16 meter squared, and this part is equal to 0. So meter squared cancel out 2 and 8, so something like this. So is equal to very nicely equal to what they call in the book. In the book it says this one is 4 centimeters. So if you set 4 centimeters, this is a meter. We like to do this. This is a meter. 4 centimeter equal to 4 times 10 to the minus 2 meter squared. So using the things equal to 1.5 80 times Newton meter times 16 and then times 10 to minus 4 meter squared. So after all that is done, the Newton meter, the unit 1 joule is equal to 1 Newton times 1 meter. So all this using calculator, then you will get 0.064 joules. 0.064 joules. So this is serving as an example how you proceed solving the problem. So you do the same thing in here. You do the integration of xb to xc, and then kx dx, and then you have 1/2 k xc squared minus xb squared. So then after that you substitute all the information there, then you will get 0.13 joules. So this is serving as a model how you're solving problems. Now we know that most of you